In this lesson titled Vertical Asymptotes, we're again going to look at a subject that we know something about already. We all should know from Algebra 2, college algebra course. We're going to look at how we find vertical asymptotes of rational functions, but then again, using the language of limits, we're going to be describing vertical asymptotes with these limits. So that's something that we maybe barely touched upon in college algebra, but it's going to be an expectation of this course that we can do that. First, let's define a vertical asymptote. I'm going to use a graph to help me do that. So let me draw kind of the graph of a rational function in here. Okay, and so we can see by looking at this graph that I've drawn that we have a vertical asymptote right here. Now I put it at 2 on this graph, but let's say that this is the line x equals a. So it could be anywhere. I just put it on a line there. So we can describe vertical asymptotes this way. We can say the line x equals a is a vertical asymptote of f of x if the limit as x approaches a from the right of f of x equals plus or minus infinity, and or the limit as x approaches a from the left of f of x equals plus or minus infinity. So similar to horizontal asymptotes, these are limits that involve infinity. They involve infinity not as the x approaches, but as the outcome as the y approaches. And they involve one-sided limits. Okay, we describe them this way, that as we approach a from one side here, from the right side, the graph's either going to go up to infinity or down to infinity. This one goes up, but it could do either. And as we approach a from the left side, okay, from the left side, it's either going to approach positive or negative infinity. This one goes towards negative, but it could do either. Okay, so vertical asymptotes, typically we describe one vertical asymptote with 2 limits. Generally it takes one from the right side, one from the left side. Describes these vertical asymptotes. Okay, this first one says describe the vertical asymptote using limits. We should all know that vertical asymptotes come from the 0 in the denominator. X in this case cannot be -2 because if it was -2 creates division by 0. So -2 is the vertical asymptote. Okay. So we're ultimately going to want these 2 limits. I'll bring the calculator back in a minute. We're going to want the limit as x approaches -2 from the right, and the limit as x approaches -2 from the left. Okay, so those 2 one-sided limits to describe this vertical asymptote. Question is, as we come from the right side of -2, does this graph go up or does it go down? Same question on the left side. Does it go up or does it go down? So if you need, this is where you might use the calculator to graph it and see it. So I've got 2 divided by x plus 2. We graph it, and sure enough it shows the behavior on the left and right side of 2, which is going to be enough for us. So let me sketch it on the graph and then we'll write out the solutions. Okay, so this is showing kind of like this, and like that. Okay, so we should be able to see pretty clearly now that as we approach -2 from the right, this graph goes up. It goes up to positive infinity. As we approach -2 from the left, this graph goes down. It gets closer to negative infinity. That's all there is to it. Alright, same thing on this one. Describe the vertical asymptote using limits. It should be clear to all of us that 3 is the number that makes the denominator become 0. So x equals 3 is where the vertical asymptote is. The question then becomes, what's the behavior on either side of 3? So let's type this in. -1 divided by x minus 3. Okay, so we can kind of see it's going up to the left. It's going to come down from the right. So if I transfer that onto graph paper, it looks about like this. Okay, that's good enough to get the idea. So I want the limit as x approaches 3 from the right. And I also want the limit as x approaches 3 from the left. So we can see from the left-hand side, graphs going up. From the right-hand side, get closer to 3, graphs going down. That's it. Next one, same directions. Function is 1 over x squared minus 4. If you were to factor that denominator, x plus 2, x minus 2, you would see that x cannot be 2 and -2. Okay, so those are our vertical asymptotes. In this one we have 2 asymptotes. So let's go ahead and graph it. So I have 1 divided by x squared minus 4. Okay, so get an image of that. I'm going to put that on the graph paper here, and then we'll write the limits. Okay, so out here on the left it did this. In between them it looked like this. And on the right it looked like this. Okay, roughly. Okay, good enough picture to get the limits. Now, we want to describe the asymptotes with limits, and in the previous 2 slides, each asymptote required 2 limits, a right and left side. Same thing's going to apply here. Since I have 2 asymptotes, I'm going to have 2 limits for each one. I'm going to have four limit statements. So I want the limit as x approaches 2 from the right, and the limit as x approaches 2 from the left. Okay, so that'll get this one. I also want the limit x approaches -2 from the right, and the limit as x approaches -2 from the left. Okay, that'll give me this one right here. Okay, so let's do this one first. As I approach 2 from the right side, graph goes up. As I approach 2 from the left side, graph goes down. Okay, now we do this one. As I approach -2, okay, -2 here from the right, graph goes down. As I approach -2 from the left of -2, graph goes up. And there's our limit statements. Last problem says find the limit as x approaches 5 from the left. Well, I would probably just start with direct substitution. If I just plug this in, we get 5 over 25 minus 25, 5 divided by 0. That's not indeterminate. Okay? And because I plugged 5 in and I got to divide by 0, that means that the denominator has 5 as a 0, which means 5 is a vertical asymptote to this particular function. If it's a vertical asymptote, that means its limit is going to equal positive or negative infinity. If the limit's going to equal positive or negative infinity because it's an asymptote, we're going to want to see the graph to determine what it actually does. So let's just make a real rough sketch of this. We know out here at 5 there's going to be an asymptote. Okay, let's use the graphing calculator to help with this. We've got x divided by x squared minus 5x. Okay, that will get the job done right there. We can see that out here it's going up. We can see that over here it's going down. I want 5 from the left side, so this is the left side of 5, which is right here. What's the function doing? It's going down to negative infinity.